First of all, you need to go to your browser, so whichever browser you use, and search your Anaconda download. And as soon as you search that, you would go to the first link, which is this. And yeah, it is quite big package, and I'll keep it on download. So you would ask, like, why Python? So Python is a language which is simpler, and with a basic syntax you can implement much more complex things. And whereas Python in general as a language is more simpler and compact to understand, whereas other languages that provide more flexibility and consistency throughout the code, but that won't help you to make these decisions and insights easier. Why Python and R are the most top popular languages for data science is that they bring the packages that are required to perform very analytical tool analytics, like EDA and plotting things and understanding and getting things done, like matplotlib and numpy. Like these are libraries like numpy, pandas, and matplotlib. These three particular libraries are more useful, and that these are the these are the packages that I am going to walk you through in this particular course. So as you see, the download has been complete, and now I'll install. So only one package is required to install on your system, that is one software that is required to install on your system, that is this Anaconda. And apart from that, nothing else is required. Everything can be done with the help of Anaconda itself. And Anaconda installs Python on your system, installs VS Code on your system, installs Spider on your system. Like Anaconda is one package that will install everything related to data science and all that. And you don't need to install Python separately. We'll wait for it to finish. So here you can see that the installation is complete, and you have to just hit next, 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 and untick this and finish. And now I'll open Anaconda Navigator. So Anaconda Navigator is one place where you can find all that packages what I was talking about, like Python, Spider, VS Code, Jupyter. Jupyter is what we are going to use as of now, and this is the UI that Anaconda Navigator provide. And here you can see that all these other packages that you can use. So you can see this Anaconda is a data science hub that involves almost everything that you can code. So you can see all these libraries and packages here, and I'm going to launch Jupyter. Actually, you can see all the environments that are set up. Means as of now we can see here the base user, base root, and so you can install other packages that are Python dependent or any other dependent packages based on your environment. Like in the Python specific environment, you can install or create or import or backup all the libraries as well as environment. So environment is like an box in which you have installed all your packages. So once you're running different code or different things, so you can set up environment in that particular manner, so that those packages which are installed in other project won't affect to to existing project. And this is what environments are set up for. Like if you have one project running on one environment and as well as next on next environment, so the libraries and packages won't affect each other, because what happens is, like, you write one particular code set of codes for given for installed packages. So if you upgrade or degrade that particular package and try to run that same code on that particular packages, it won't run. It will yield errors that are very much non-solvable, I would say, because once you install things that are incompatible, it will yield errors, and we have to minimize those. And that is the reason why we have to use environments in the production environment. So as of now we are going to continue with this base root. and I'm going to launch Jupyter Notebook. And by default, a notebook is going to launch in your browser. So I'm just going to select Chrome, and you can see here is the notebook that has been launched. So actually the path you can see here is nothing but your system path. So this is what you can see over here. So I'm now going to create a new Python kernel. Actually, you can create a new folder as of now, and we will continue in that. You can just select this and rename from here. I would say walkthrough Python libraries. And now I'm going to open this folder and create a new Python kernel. Now, what is Python kernel or Python notebook? So actually, this is your notebook that we are creating right now. It is a set of codes that you run in sequential manner. It is not exact work environment or things. This is, you understand, like it's a sketchbook. Like you keep on sketching on just doing all the analysis and permutations on this notebook, which really does not translate to your real or main notebook. Means something like that, a document or something like that. It's just a scratchboard or a blackboard where you are doing all the scribbling things that really don't make into the production. And this the notebook where you perform EDA analysis, insights, see how the trend of of your data is, or pre-process your data. And these are the small steps that you are taking in order to make your data more representable, as well as process it for the further steps. So I will just rename this workbook or notebook to something like installation. And you can see this particular thing in your document section. For example, notebooks and libraries. Libraries should be in C. So actually, you have to go in your C drive and users. And currently, I'm logged through this Rushi as an user. So you have to use your current logged in user, and you can find all your projects and directories over here. And to access something apart from C drive, you have to do certain steps that we are not going to set up here. So this is your Python file, Jupyter file that is been located on your system. So here you can put in your CSV file or what all the files you need to process your data, the raw data as well. So here we will run this pip freeze. So pip freeze is command. You have to hit means you have to run this particular cell with hitting shift and enter. Shift and enter results in executing this particular cell. So consider these cells, and you can see the number which says that the current execution cell number, like at what time this particular cell was executed. Now if I run something else, print, so this says the number of time particular cell has been executed from the inception of your kernel. Kernel is what is a session that you execute or start with each and every code execution. Once you start any Jupyter file, the kernel will automatically start, and you have to just write or execute your code, and kernel will handle everything. Now if I restart this particular kernel, it will erase everything first of all, and once you execute any particular command, it will give you the first number over here, because it is first command or first thing that you have executed, and so on and so forth. If this is all kernel dependent, means once you restart kernel, this number doesn't make any sense, but it will just give you an idea like how the code was executed. For example, if I define something like this new string and execute this, And if I run over here that same thing, you see, if I started a kernel and start executing these things, RG was not defined. But here you can see that RG was defined at instruction 3, and then at fourth you have executed what is in that RG. So this way you can see that the flow can be varied, means interchanged, but in general you can see the numbers that represent the flow. You can execute this command again and again multiple times, and you might get confused like how you can run RJ before defining it. So if I restart the kernel, and you see that it will give me an error when I start executing things. See, RG is not defined if because the chronological order of the code doesn't match the execution code. Now I have to define it and then use it. So this is how it is done. So we will see how to execute or install packages. So as of now, I will just give you an overview like how and what are the shortcuts we need to use in Jupyter. So A means you add something below, and B means you add something above. So you have to click over here and then execute any particular commands or shortcuts. If you select inside and hit A, then it wouldn't add anything. And for deleting any particular cell, like I will write something so that you can keep the track of what is been deleted. So I will hit double D in order to delete particular cell, so and so forth. And to know what are the shortcuts, you can use help or edit shortcuts so that you can see what are the shortcuts. Shortcuts are nothing but you will get used to it over the time. Okay, so now I'm going to install the libraries that we can or we are going to use. So as of now, these are the default libraries that have been installed via Anaconda. Means Anaconda installed these packages by default. And yes, we are going to install that are required, like NumPy. So to install NumPy, we just write pip install NumPy, and there we go. It shift enter to execute that particular cell. Okay, so now it's already installed, and now we are going to run pandas. So pandas and NumPy are two libraries that we are mostly going to use in order to wrangle the data, to handle missing values, to transform data from one particular structure to something else that your flow might require. So once you have installed NumPy and Panda, you can import those particular thing via this via this command NumPy as np. So import NumPy as np and import pandas as pd. So these are the standard abbreviations we use. Most of the coders use to import things. You can import by something else as well, and it will result the same way how it should work. So for example, now I will define something with using NumPy. So NumPy equals np dot array and pass in your numbers. It will So actually now we have to pass this particular thing in a function. So because np array is a function, array is function of NumPy, so you have to use dot operator to pass your function name, and opening bracket and closing bracket to pass any parameters within those particular function. Okay, and one more shortcut is that to see what your syntax uh, or what your functions require. So you can use shift and tab clicking just after the opening of this function. You can see if I click over here and hit shift tab, it wouldn't give me anything that is required. So to understand what particular inputs the function is required, you have to just click shift tab after the opening brackets, and you can see the entire thing over here. So what this particular thing is, the documentation for this particular library, and to be specific, of this particular function. So when numpy was been defined, and when numpy was defined, you define this documentation as well with it, the numpy array documentation with it. So you can see you have to pass an object, array like object, like it should be a string of things or numbers for array to work. And you can see the examples right down here. So these are the examples that you can use ready-madely, but definitely it won't be tailored to your use case. You might need something else, but yes, you can perform these all operations with this particular array function. So we can use, you can put this thing into a variable like array, and it would contain everything that we have defined from here. Okay, so before proceeding further, I will just explain you the basics of Python or any other language. So there are a few things that are required to understand. First of all, what is integer? So shift M or selecting this and hitting M will just make this cell markdown cell. So markdown cell is nothing but a heading for particular UI. Particular cell means it is just for your understanding that you are doing some actions or performing some steps from here onwards, that that you define here. Like I am going to perform integer or explain integer, so I will just use explanation, and now you would understand like this is integer explanation. So this way this headings comes handy. So what are integers? Int or integers in any language, integers are the numbers, like so a equals to something, so this is number. So you can see the type of variable a. So what is type of a? Like the type function, you can use it everywhere to understand what type of variable or things you have defined in any variable. Like if I have defined string, so in Python you can define string with this double quotes or single quotes, and when you define string, it just returns that yeah, it is string variable. And to get more in-depth parameters, what to pass and what to not, you can always use shift tab after opening the braces, and you can understand like what inputs to pass to particular function. Because you are not a genius, or nobody can be, understanding what syntax to be passed and how to use any function, you can always use the shift tab to get what parameters to pass. These are the basic insights and shortcuts that will help you to maximize and optimizing things, or implementing things more efficiently, rather just googling how to pass, what how to check. Like what would you do in normal scenario is like Python, how to get type of variable, and it would yield the same thing. Like the type function is used to do things, and this also result the same thing. So the hassle of going and finding things is cut down short in few steps. So this is a string, and we have seen the numbers, and now we will see what is list. So list is nothing but set of objects or list a set of objects, integer, variables. You can define anything in this list. List can be data frame, pandas, numpys, anything you can define in list, and you can see the list over here. So in Python you don't have many data types like that you can see in C language and in other languages. So here you can see the type of that particular variable, and it is list. And you can define a dictionary. These are the different data types. So dictionary always starts with curly braces, and there are key and value for any dictionary. So key can be anything. It can be list, it can be dictionary, sorry, it can be, consider this name or key as an things to get, means like a name, and then value would be something else. For example, I would say key is like name and value is like Rishikesh, and now key is like phone number and value is something like this. So here you are defining a list, sorry, a dictionary in this manner. So colon always use in between key and value. So colon is a syntax that we always use as separator between key and value. And after executing this, oh sorry, it is semicolon over here. Once you execute that, you see it says it is dict. So dict is a type name for dictionary in Python. So the key is the list, the dictionary is the array, the numpy array. Now you can see the type of this as well. It says the numpy array because it is an object of numpy and it is numpy array. So nd array. You can define 2-dimensional, 3-dimensional, 4-dimensional, whatever dimensional of array using this method. Now how can you define 2-dimensional array? Just use same technique, and this way you define a 2-dimensional array, and you can see the type as well as nd array. So next we are going to see how to access the data of list. For example, I will define dict, and never, one more thing to note, that never define your variables with the system identifiers like dict, list, type. These are the identifiers that we used in a language, and once you define those with some variable, you have to just restart your kernel in order to erase that mistake. For example, I will define dict, and now I will just call over here dict. But whenever I want to convert something to dict and we use dict and pass in here something, it wouldn't execute things. For example, I will show you with the help of list. So I'm going to define list 1 with something called as 23. Okay, this is a list, and you can just print out the list. So you can see it is well correctly yielding proper results. And now there is one way of defining a list with passing parameters. Okay, this is the way we get list out of thing. Okay, and now if I define list as something like this, okay, now I have defined list with string and try to do same operation again, it will give me an error because str object cannot be callable. Why you get this error? Because you have defined string as list over here. This is the string that you have defined as a list, And now Python does not understand what list is, means what actual list is. You have just overridden the Python variables. So now to overcome this result, you have to just restart your kernel, which will just erase everything what you have done as of now. Erase everything in the sense like erase everything from the memory. And now after executing things again, you will get your things going. So never define variables of define variables with system identifiers. And I made same mistake again. So I'm going to show you a way to access your list. Now, for example, you have defined a list, okay, and how to fetch a list object. Like for example, you want this first element of the list, so you will just write the list and pass the index of that list. Okay, for example, now in Python language, index always starts from 0. So if you mistakenly pass 1 considering that this uh, result, then you will be misleading, and it will give an incorrect result that what you're looking for. So what you can do in this case to get first element is always this: pass 0 for first element, pass 1, and so forth for whatever the nth element you want. And to get the last element, you have to just use negative value. So -1 is the last element. In this case, I will give more parameters and the more variables, so more elements in this list. And you can see the last element is 2343. And to get second last element, you have to just use -2. And one more thing to notice is that you see this opening and closing of commas, inverted commas. So what that defines is that this is list. Now I will get the type of this particular thing is str. Str means the list. So getting the type of what? Type of this element. Okay. -2 resembles second last element of this list 1. So in this way you are getting type of that element. Now if I put in -1, means the element of the type of this element, you would get integer, because you have not used colon or not commas, inverted commas to define it. So it is the way, and the lists are used and operate, and means the data has been fetched in this particular manner. Now I'm going to define a dictionary, and in same way I will show you how you can get the result. In dictionary, you can access your same thing passing the names. Okay, you can get the values via names. For example, if I pass over here name, you would get result as a value of that name. Same goes for age. Okay, because those are defined as a string, you won't able to access this way. Is not defined. You can't define numbers as well, I guess. Okay, you can define numbers and get the result. Okay, you can define numbers as well in defining a list dictionary, and this way you can get name of particular, sorry, value of particular dictionary element. So here you go guys, this was the first introduction video, and we will just discover more things that are required for basic understanding of a language in further videos. Thank you for watching, and have a good coding and practice the things that are required for this particular thing.